As I was saying, I had to drill a hole in this, but the leads won't fit through. So, the easiest solution is to restrip the ends of the wires that will attach to the circuit board. That is a wire stripper. Cut the ends because they have solder on them. Now we slide the wires through. Black. Red. And solder them onto the circuit board in the correct color. Black. Twist it. Screw it. We'll just solder it on the bottom. It's not going through the hole. These are the vicissitudes or difficulties you run in as an electronics technician. I need helpy hands again. I can do this because they've given me more than enough room to snake the wires around the circuit board. Incidentally, you've learned a little electrical engineering. Altering the board, the enclosure, by drilling an extra hole in it is called electrical engineering. Simply wiring stuff up and using a test equipment to make sure that voltages, currents, frequencies are okay is the job of an electronics technician. Simply stuffing components like we are doing into a kit is assembly work. I'm going to add some solder to this. Nothing's working. What's going on? My iron's unplugged. Okay, we'll let the iron heat up. The cigarette went out. It's okay for me to smoke cigarettes. I'm a scientist from the 1950s. The only difference is my videos are not in black and white. Now, like I said, resistors limit power, voltage. How do they do that? They radiate it as heat so that the input power is less than the output power because of heat loss. This is important in order to do such things as mainly provide the correct voltage and power on the lead of other types of components. What do I mean by components? I already showed you in this disgustingly wired circuit board with alligator clips. Someone must have been on a lot of alcohol when they wired this one up. Diode, electrolytic capacitors, a voltage regulator. All of these other components take specific amounts of power to power on. The power in this case is represented as voltage. That will be in a schematic or a diagram of the electrical circuit, so you'll automatically know what kind and amount and ohmage resistors you need to wire your circuit up. You can put your circuit on a breadboard, such as this, and do research. I'm going to put an AM radio on my breadboard. I have knobs, switches, dials, tuning, internal antenna. This is for engineering work. Now, the type of chip that I'm going to use is an AM radio chip whose frequency is controlled by discrete components, capacitors, inductors, and of course our favorite things, resistors. I'm going to breadboard it, use some basic electronics math, not calculus even, and do little calculations here and there, and switch components, but mainly play around to try to get the radio to operate in the low frequency range. I want a low frequency receiver. How would I know if I got that? I can hook it up to my, well, either my, it's not plugged in, frequency counter. And this will show the waveform and frequency as well. It's a function generator. I'd rather use the frequency counter. Low wave is low frequency. Let's see if I can do it or not. Let's get back to the video. Well, at least you can't burn wires. We'll add some more solder and make sure that's in there well. You will burn yourself, but that's part of the job. Wait. Try moving it. It's in there well. And that was black. We did it correctly. Now we'll do red. You can see kits don't always go your way, but you can I don't want just a short to anything else. Bend it. Hold it on its connection. Solder has already melted, but to be sure, I will add more solder. Hold it. Hold it. Try pulling on it. It's solidly in there. And is it the right one? Red. I wish I had a laser pointer. You can see the laser on the other side of the board. Yes, red, because there's the switch. Let's put it in the enclosure. We'll snake the wires that way. And look, I told you it would fit perfectly. Pull the wires out. We want to make sure the switch is going into the switch holder, which it has. But the red wire is in the way, so we'll simply move the red wire to the side of the switch. Pull the wires out. The switch has free room to move. But watch what happens. There are 4 screws to hold this kit together. But if I do that, ready? There you go. It falls out. And this is too deep. I'll show you a quick trick to rectifying this problem. Oh, I see. Okay, I see what they're doing. I see. Okay. I see what they're doing. They're going to hold it in by a washer and a nut for the switches. Otherwise, that's going to glue it. Hand tighten. And tighten for expedience. Don't cross thread. This is not going on. Why isn't it going on? Oh, I see. Okay. Alright, I gotta show you something else you have to do. Yes, on switches. You will notice on a switch that they're not a little extended piece of metal. Bend it off. Bend off that piece of metal. I never have used them. Bend it off. Now, it will lie flush against the silk screened, beautiful wire's okay. Is it that? Okay, now it'll work. Washer. Now we have room for the nut. Now let's make sure that nut is tight. Good, you don't have to go crazy. Where's the switch? Make sure the switch, well, we don't know where it is. We're gonna have to wait. Let's do the other nut. Where is the other nut?